All right. Now, special Pythagorean triplets. The problem 9 of Project Euler. So a Pythagorean triplet is a set of three natural numbers a, b, and c, while a is less than b and b is less than c, for which the a to power of 2 plus b to power of 2 is 3 to power of 2. For example, 3, 4, and 5 are three Pythagorean numbers because 3 to power of 2 plus 4 to power of 2 is 5 to power of 2, and which and yeah. And now it says that there exists exactly one Pythagorean triplet for which a plus b plus c is 1000. Find the product of a times b times c. Then what are we supposed to do here is to find three integers that are Pythagorean triplets and at the same time has the sum of 1000. So let's talk about the why do we have that a to power of 2 plus b to power of a times a plus b times b is equal to c times c. What you probably know this equation when you are talking about normal triangle. And the two sides of the triangle, which it should be something like this. And this side, and this side is A, this side is B, and this side is C. So here, and to make sure if a triangle is a normal triangle, that equation should work on that triangle. And that equation comes from another equation, which this is a special part of that. We call it the cosine equation, where a to power of 2 plus b to power of 2 plus ab times cosine of and that angle is equal to c to power of 2. And you can find more about it with the name of law of cosines in the Wikipedia. Later you will, yeah. It's and this equation will be work on all triangles. All triangles should satisfy this equation. So when the angle is 90 degree, then we know that the cosine of 90 degree, which is the same as cosine of pi over 2 is equal to 0. So 2 times a times b times that's times and times cosine of that angle, which is equal to pi over 2 is 0. So in normal triangle, a to power of 2 plus b to power of 2 should be equal to c to power of 2. So what we know here is that we have three numbers, a, b, and c. A plus b plus c should be equal to 1000, and a to power of 2 plus b to power of 2 is equal to c to power of 2. So if we use 3 for loops, one for A. It's 4 over A values, 4 over B values, and 4 over C values. So we know something, that the sum of them should be 1000. So we actually can use that as a way to reduce our initial our range of loops. So if the first one starts from 1000, so this one can be started from just the value of the previous one, and this one can be used after the previous of after value of the previous one. And why is that? Because if A, B, and C are working, also B and A and C is accepted. And we know that C should be greater than A and B. So by knowing this, and we don't want, because this is a huge range of numbers, so and to reduce the repetitions, I use a little bit thing to 1000, and I come down until 0. And then I start from the previous value until I come down to 0. And why is that? Because if we have checked the number once, so it's already checked, we don't need to check it again. And then Z has the similar thing. So I will check if I to power of 2, which is for the value of Z. Why? I again said that the C should has the greatest value, so it should start from 1000 and come down until we find a value that satisfies it. Is equal to J to power of 2 plus Z to power of 2. And at the same time, I plus G plus Z should be equal to 1000. If that's the case, then the value is the value that we want. Right. Yeah. And the total numbers that we are looking here is hugely the number of times that this if condition is checked is greatly less than 1000 to power of 3. And well, just to compare the times that this for loop will be checked, it's almost equal to 1000 times 999 over 2 over 2. Quite less than the real times that if there would be no conditions, and this one is also started from the 1000 itself, would be checked. And now, if I check the output is 3187 5000, and the value is the same thing. I'm done.